Hey everyone, this is Remy, and this video is going to cover the Math 124 note outline for section 2.5, which is on transformations. So this whole section deals with graphing functions, and to do that we're going to take the equations of the functions and analyze them and see what that can tell us about how the graph should look. And when we do this, we're pretty much always going to start out with one of these basic functions. They're also sometimes called parent functions, and these 7 here are the ones I think that are used the most often, and more are found on the inside cover of your textbook or on page 159. So I'm just going to review these. So these ones you should definitely have memorized, meaning if you see the equation for it, you should know what that is going to look like on a graph. So this one is y equals x. This is the identity function. So if you see y equals x, it looks like this. It's a straight line. It goes through 1, 1, 2, 2, 3, 3, 4, 4, and so on. And then this one's a square function. So this is for y equals x squared. So for y equals x squared, if you graph that, it will always come out to look like this, and this is called a parabola. And then next is the square root function, y equals root x, and that will turn out to look like this. It starts at 0, 0, goes through 1, 1, goes through 4, 2, and so on. Then the cubing function, y equals x cubed, x to the 3rd power, looks like this. Goes through 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. Creates that shape. And then down here, the cube root function, so y equals the cube root of x, looks like this. The reciprocal function, y equals 1 over x, looks like this. So this one has 2 parts to it that are kind of separate. There's actually a vertical asymptote right down the y-axis, meaning the graph doesn't actually touch the y-axis, and same thing for the x-axis. There's what we call a horizontal asymptote, and the graph never actually touches the x-axis, but has kind of a part over here and a part over here. And then lastly, the absolute value function, y equals the absolute value of x, looks like this. So these are our basic functions, or sometimes called the parent functions, and we're going to base all of our other graphs off of one of these functions. So since we're talking about transformations, there's multiple types of transformations. You can shift a graph right or left or up or down. Or you could also take a graph and reflect it, like mirror it. Or you can stretch a graph, or you can kind of shrink the graph, and those are all the transformations that we're going to talk about today, and we're going to talk about them one at a time, and then at the end of the notes we're going to talk about doing multiple transformations at the same time. So we're going to start off with the vertical and horizontal translations. So these ones are purely moving a graph up or down vertically, or right or left horizontally. So we'd have a function, y equals f of x, and if there's a number added to that function or subtracted from that function, then you would shift the graph up or down respectively. And the key thing we want to note here is that that number is on the outside of the whole function. And whenever it's added or subtracted to the outside of the whole function, that's when you're going to get moving up and down. And naturally, if you have a plus b, it's going to shift the whole graph up b units, and if you have a minus b, then you shift the graph down b units. And then horizontal translations, to move it right and left, that's kind of what we think of as being inside the function, so it's added or subtracted inside of the function. And I also like to think of this as being maybe the numbers being directly added to or subtracted from the x itself. And when that happens, the graph will get shifted left or right. And so what this is saying down here is if you have the x minus a number, then you're going to shift right d units, and a number added to the x, you're going to shift everything left d units. So for now, let's just practice these types of translations on the next page. We're going to practice identifying when it's going to be up or down or left or right. So now at the top of page 2, this example has 4 parts to it, and for each of the 4 parts we're starting with the graph of this same function, f of x equals x squared. So I'm just going to do a sketch of that function. So if you look on the previous page and you look this function up, x squared, it gives you the shape of what's called a parabola. And this is just going to be a sketch, so nothing absolutely perfect, but x squared basically looks like that. That's a parabola. And for each of these, we're going to say what transformation happens starting with this graph and then coming to this new graph, g of x equals x squared minus 5, or x squared plus 5, or x minus 5 squared, or x plus 5 squared. And if you look at parts A and B, we have a minus 5 and a plus 5 attached on to this original function. We have x squared and then subtracting 5, or x squared and then adding 5. And then in parts C and D, it's slightly different, because instead of being added to the outside of the function, it's kind of being added or subtracted on the inside of the function directly next to the x. And that shows what we were talking about here, that sometimes the numbers being added to or subtracted from on the outside of the function, that means you move up or down. But if it's on the inside of the function, adding or subtracting to the x itself, then you're moving left and right. So you can refer back to what this box is saying. And so I'm just going to go through, how I usually think of these. So these two again are on the outside, minus 5 plus 5 on the outside of the x squared. So these two mean up and down. A minus 5 at the end of the function on the outside of the function means shift everything down 5. But if it says plus 5 added to the outside of the function, then you move everything up 5 units. And then C and D, since these minus 5s and plus 5s are on the inside of the function directly attached to the x, that's going to tell you left and right. But it might be a little bit backwards compared to what you might think. So this minus 5 is actually telling you to go right 5, whereas the plus 5 tells you to move everything left 5. So for all 4 of these, we see that these are all kind of a new version of x squared. Therefore, you start with the graph of x squared, which looks like this, and then you use the minus 5 and the plus 5, figuring out where it is in the function to tell you whether you need to move down, up, right, or left 5. So say part C, for example. This one we see the x minus 5, the whole thing squared, so we know that we need to go right 5. So that means in order to graph this g of x function, we would first graph this function and then move the entire function, every point on the graph, right 5. So if we move this whole thing right 5, we would end up with this g of x graph. So that's up, down, left, right. Now let's talk about reflections. 2 types of reflections. First, you could reflect a graph across the x-axis horizontally, or you can also reflect a graph across the y-axis vertically. So this also has kind of an inside the function, outside the function difference. So for across the x-axis, we see this minus in front of the whole function. So this one is a minus 1 times the entire function. So if you have a function and then you multiply that function by a -1 out in front, then you're going to get a reflection across the x-axis, and that would be your new graph. And then let's compare it to this one. Here, the minus is directly attached to the x. It's not out in front. It's not multiplied to the whole function. The minus is multiplied only to the x. So in that case, when you have the -1 times the x only, then you'll get a reflection across the y-axis instead. So let's do some examples of that. So here we're going to start with the graph of f of x equals the absolute value of x, and then we're going to see what transformation happens from that to g of x equals negative absolute value of x. So when I compare these two functions, I see that if I take this part and multiply the whole thing, the entire function, by -1, I get this. So this is a -1 times the entire function. Therefore, it's a reflection across the x-axis, because that's what we wrote up here. So, reflect across the x-axis. Here I'm going to graph f of x, and then over here we'll graph g of x. So f of x is the absolute value of x, and if you do go back to page 1 and you look for that graph, it's going to look like this. It looks like a V, a perfect V. So this is what the absolute value of x graph looks like. And we're going from this graph to this graph, and we analyzed what's going on with this minus times the entire original function, so we need to reflect it across the x-axis. So I'm going to take this and reflect it as if the x-axis is acting like a mirror. And that's going to give me a graph that looks like an upside down V. So this is absolute value of x, that's what that would look like, and then this graph over here is minus the absolute value of x, what that would look like. So that's an x-axis reflection. And then let's compare that to part B. The original graph that we're going to start with, f of x, is the cube root of x, and then we want to go from that to g of x equals the cube root of negative x. So this time we don't have the -1 out in front times the entire original function, but we have a -1 times the x value. So this time we have -1 times the x only. And if you notice that happening, then you know you're going to have a reflection across the y-axis. So again, we'll start with this graph. I'll label my axes. So over here, I'm going to graph f of x. And if you look back on page 1 and you look at the cube root of x, that looks like something like this. And now, since it's a -1 times the x only, we know that we need to reflect the graph, the original graph, across the y-axis this time. So now the y-axis is acting like a mirror. So if that's acting like a mirror, this part is going to get reflected that way, and then this part down here is going to get reflected that way. So this goes like that, and then this one goes more like that. Something like that, just a sketch. And this is our new graph, g of x. So this one over here we graphed, this is just the cube root of x, and then this graph is the cube root of minus x, what that would look like. So that's the idea of reflecting across the x-axis or the y-axis. Now let's go on to page 3, and we'll talk about vertical stretching of a graph or shrinking, or horizontal stretching of a graph or shrinking.